Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, good evening for you guys. My name is Iswandi with name 2213440001 from Polytechnic Negeri Bandung, 4th year Diploma in Telecommunication Engineering. Today I will present the outcome of my internship at EarnUp Indonesia, and it's not just about routine maintenance, it's about identifying operational inefficiency and proposing a technical solution. As you guys can see, my title is Design and Build Localizer Scope as a prototype of portable DDM SDM signal localizer measuring instrument based on SDR and embedded system. Okay, next. I was based at Jakarta Air Traffic Center, Service Center or JATS. This is the heart of Indonesian air navigation, managing the flight information region or FIR for the western of the part of this country. Working here means building a critical infrastructure where safety is non-negotiable and the tolerance for error is zero. Okay, next. And when I'm doing internship, I'm validating a lot of theory that I got in college. And there's a three main part, and those are radio frequency, surveillance and data processing, navigation and precision. Okay. At radio frequency, there is a two unit that main part is radio frequency. There is radio communication and also SRSJ or system recording switching and jaringan. Those are unit that maintenance the interface or the fiber optic, also the radio transmitter or receiver. We monitor the transceiver of the radio that we ensure the RSSI stay within negative 110 to negative 120 dBm to maintain a healthy link budget for pilot controller communication. Next, that's surveillance and data processing. In surveillance unit and also DPS, in surveillance, analyze how data from various sensor or radar, like the first picture like this is the PSR or SSR, to find out the location of aircraft or target in the air using the signal. And also there is a SMR or surface monitoring system to find out the target in the area of airport using different signal reception time ranges. Also there is a DSP, also like PSR and MSSR, is to find out the position of the target or aircraft by changing the aircraft transponder information. Also there is a SMS or surveillance monitoring system. This is a tool that find out the quality of data at each airport that send to JATS. But also there is a MLAT. I'm not putting a picture here, but MLAT is like a SMR, but the result is only the vehicle around the airport, but using a transponder. Also, by all of those radar data will enter the RDPS unit and it will be processed into a display that as you guys can see, this is the display that will used by the controller worker position in the operational room to guide the aircraft or the plane in the air. Okay, next is navigation and precision. However, this is the most critical insight came from the navigation unit. Here I work at the instrument landing system, ELS, specifically the localizer. And this is also the ELS, but this is the antenna glide path. And also there is a tool that for navigating plane. This is the default. Those are maintained by navigation unit that the system requires precise measurement of two modulation tone. 90 and 150 Hz, and this is also the peer portable ALS receiver. Okay, we now in the background why I use or pick this project. So the problem to check the signal parameter by technician in navigation unit is use standard portable ALS receiver like this or this one. So the problem is the existing tool is bulky, heavy, and extremely expensive. So bringing this heavy equipment to the end of the runway for daily check is inefficient. There is high chance to the technician to fall off because the bulky, heavy, and big equipment. So my solution is to engineer a low-cost handle alternative using SSDR technology to offer comparable function for pre-check purposes. So this is the design of my project. There is localizer scope. Those are a lot of subsystem. There is 4 subsystem. So we move into the first subsystem. That is power supply. So I use a lot of module to making the subsystem, but the end I make a stable output of 5.1 volt that can power the device for hours without external cable. This is as you guys can see. And next is the signal acquisition. So in this subsystem, I didn't just buy a random antenna. I calculated the frequency and also the length of the antenna using this formula. Targeting the localizer frequency is at 108 MHz. I designed a half-wave dipole antenna. So you guys can see this is the antenna based on the wavelength formula. And then the total length is to be 1.32 or 321 meters. This custom tuning ensures maximum sensitivity to the specific ALS frequencies. And we next into a processing signal. Now, this is the core intelligence of the signal processing. This block diagram running on the range peak. I use a GNU radio to process the raw IQ data. I designed a flow graph that filters the signal and isolate the 90 and 150 Hz tones. Since the standard block were insufficient, so I make a custom block Python. This is the custom block Python that I make to calculate the depth of modulation. So I can make a DDM, that is the difference of depth modulation, and also the SDM, sum of depth modulation. The DM and SDM is the parameter signal for localizer that say the DDM is the center line of the runway and the SDM is the verifying data, and by the EKO standard the DDM should be 0 and the SDM should be around 40%. So we next move into the simulation. As you guys can see, the following signal process by diagram, it displayed the DDM and SDM radar. DDM and SDM data received by both dipole and SDR antennas. Although the optimization is still needed, this demonstrates that the block diagram is functioning properly. Yeah, this is the picture that the most precise value that I take. And the last one is subsystem of user interface. Although the system design is underway, the current implementation phase still faces significant technical challenges in the user interface subsystem. The connection between the orange P and the LCD, my analysis identified the root caused by the kernel incompatibility. The chipset of the Orange P and the LCD is not right. Maybe because uh, the Linux kernel that used on Orange P is too modern, but the LCD is still ya, terlalu lama gitu. But I attempted to bypass this using what should I say? User space drive or SPI loopback test. Okay, this is the attempt atau percobaan eksperimen that I use for connecting Orange P and LCD. But with all those three experiments, or I attempted to bypass this problem, it's still not working. The backtest said that the pin for sending data and the receiver pin for data is not same. It means the kernel still not the good way. So the conclusion is the localizer scope should be able to design a completely standalone measuring instrument, integrating a signal acquisition and data visualization in a single handheld device. And also, the use of SDR has been proven to be able to replace the basic function and measuring instrument, and has been proven to be effective and has sufficient accuracy to replace the basic function of high-cost commercial measuring instrument, making an efficient solution for pre-check and purposes in the field. Thank you for you guys for hearing me presentation. Goodbye.